A probability distribution is a table listing each possible outcome of an experiment and its corresponding probability. All right. So distribution just means table. And what you have is a table of every single possible outcome and its probability. Okay. So it's a big table sometimes because there's going to be however many, whatever can happen in this experiment. You've got to list everything that can happen and its probability. Number 8 says construct a probability distribution for the sum of the numbers showing when 2 dice are rolled. So it's kind of important that you understand we're talking about the sum of the numbers. Okay, that's what's called your variable, your random variable. X is the sum of the numbers. So if you look, what could possibly happen? Well, the smallest sum of the numbers is 2. If you roll 2 ones, you get a sum of 2. You understand what I'm saying? Okay, so here's what I'm going to do. I'm going to make this probability distribution, and I'm going to say X, and I'm going to say PX, okay? X being whatever that sum could be, and PX being whatever that probability would be. So if the sum is 2, okay, there's only one outcome out of 36 possibilities, so that probability is 1 over 36. So a probability distribution is a table that lists all of the possibilities, all of the possible outcomes for, in this case, the sum of the numbers. So what else could happen? Well, look at these two. These two show a sum of 3, the probability being 2 outcomes out of 36 total. If you notice what else could happen, there could be a sum of 3 or 4. I see 3 of those out of 36. Or a sum of 5. It looks like there are 4 of those. 4 and 1, 3 and 2, 2 and 3, 1 and 4. There are, did I do that right? Sum of 5, there are 4 of them out of 36. Okay. Sum of 6, there are 5 of them out of 36. A sum of 7, there are 1, 2, 3, 4, 5, 6. There are 6 of them. So, think about what I'm saying here is what's the probability that I roll a 7? 6 out of 36, right? Or reduces to 1/6. You could reduce these fractions if you'd like, but I think it's easier to look at if you don't. We could get an 8. So 1, 2, 3, 4, 5. There are 5 8s, so 5 36. We could get a sum of 9, and there are 4 of them. We could get a sum of 10, and there are 3 of them. We could get a sum of 11, and there are 2 of them. Or we could get a sum of 12, and there's only 1 of them. Okay, that is a probability distribution. That's probably a bigger one than you'll see most of the times, but I wanted to give you a big one so I think the bigger it is, the more obvious it is what I'm doing. I'm listing all of the probabilities or all of the possible things that could happen and their probabilities. Now, what would I get if I added up all of those fractions right there? You'd get 1, right? It would have to be all of the possible outcomes are going to add up to 1. All right. Remember, we're talking about probabilities here. So those numbers have to be in between 0 and 1, right? Every one of those fractions is a number between 0 and 1. If you got a number bigger than 1, or if you got a negative number, that wouldn't be good. That wouldn't be a probability. So that couldn't be a probability distribution. Number 7. 7? Why did I say 7? Number 9. Let's try this again. Susan is a college student who receives heavy sweaters from her aunt at the first sign of cold weather. Susan has determined that the probability that a sweater is the wrong size is 0.47, and the probability that it's a loud color or bright, obnoxious color is 0.59. And the probability that it's both the wrong size and loud color is 0.31. Part A says find the probability that the sweater is the correct size and not a loud color. This problem is really hard to do in your head without showing any kind of work, okay? So quit trying to do that, please. Let's go back and look at what they give me. So I notice it says the probability that it's the wrong size is 0.47. So what I'm going to do is over here, I'm going to say probability of W for wrong size is 0.47. And the probability that it's a loud color is 0.59. So I'm going to say probability, or PL for loud color, is 0.59. The probability that it's both wrong size and loud color, so probability of wrong and loud, is 0.31. So I start by just writing down, kind of summarizing the information that I'm given. A lot of the times I can use a formula like the union rule, or I can draw a Venn diagram, or one or the other is what I'm probably going to have to do. And then I look at what they're asking me again. Find the probability this sweater is the correct size and not a loud color. Okay, so correct. That's a weird way of putting it, because they haven't really said the word correct in the problem. But if you think about what it means by correct size, it means not wrong. All right, so use the language that we've been using in this chapter. Correct is the same thing as saying not wrong. So they want not wrong and not loud. Probability that it's not wrong and not loud. That's what I'm trying to find. Now, I can't really use the union rule here. The union rule is very specific in what it wants. I wouldn't use the union rule here because it's talking about not wrong and not loud. I would need to be using not wrong and not loud in my formula, and I don't really have that, so that's not what I would use. I would also need a union, and I don't see a union. So I think my fallback is almost always going to be I'm going to draw a Venn diagram. So let's draw a Venn diagram. There are two sets, W and L. Don't forget to draw the box around. We draw the box because we want to have 4 regions in our picture here. Make sure we have 4 regions that we can label. So go back and look at our given information. Probability of wrong size is 0.47. I've got too many holes to fill. I don't know which one of those 2 spots to put it in. Okay, so go to the overlap where it says wrong and loud. I know that I can put 0.31 right there. That's where wrong and loud would be. Then I can fill in the probability of wrong because I know probability of that W circle is 0.47. So if you do 0.47 minus 0.31, 0.16 must be in that other spot. 0.16 must be right there. Okay. Similarly for L, I know L is 0.59. The entire L circle is 0.59. So subtract 0.31. That's 0.28 is going to go right here. Now, I've got 3 of the 4 spaces filled in. The space outside of the circles, I know everything adds up to 1. So what I could do is just subtract all of those numbers, 16, 31, and 28. Subtract those from 1. .25 goes outside there. If I can get all that labeled, I should be able to answer anything that they ask me. Okay? So not wrong and not loud. Okay? Not wrong is 0.25 and 0.28. We're going to intersect that with not loud, which is 0.25 and 0.16. So if you look at the intersection, that answer is going to be 0.25. Not wrong and not loud is 0.25. Now, the nice thing about drawing a Venn diagram is you should be able to answer the next question as well. We've already done all of the work. Next, we're just going to answer the question. We want the probability that the sweater is the correct size or is not loud. So correct size means not wrong or not loud. Not wrong or not loud. Probability of that. So look at not wrong. Not wrong is 0.25 and 0.28. We're going to union that with not loud, which was 0.25 and 0.16. So if you think about the union, you're going to put those numbers together. The union is going to be 0.25 plus 0.28 plus 0.16. Those are the three numbers. Those three numbers need to be put together. So 25, 28, and 16. 0.25 plus 0.28 plus 0.16, 0.69. That's the answer. 0.69.